Morning, judges. My name is Agus Ril from the Energy University. So I would like to present my idea with title of Sustainable Rubberized Mortar for Thermal Insulation with Graphene Innovation of the invention. In recent years, the thermal behavior of cementitious material has drawn significant attention due to its potential impact on energy saving. While numerous studies have investigated the individual effect of additives like rubber or graphene plate on the thermal performance of cementitious material, and the thermal behavioral conflict stemming from the differing Ponon transport mechanism of graphene and rubber. Moreover, the combined impact of this material and the optimal proportion remains unexplored. Therefore, this study employs experimental to systematically investigate the thermal behavior of cementitious material incorporating a hybrid combination of rubber and graphene plate. The result of this study or research has been published in Result in Engineering, which is this one is the Q1 journal Web of Science, to prove that the idea is novel. The purpose of this invention or innovation first to enhance the thermal insulation through the incorporation of recycled rubber particle, and also the second to enhance mechanical strength by integrating graphene flags and silica fume, and third to promote energy efficient and eco-friendly construction. And then number 4 to convert recycle and the industrial waste such as the used tire into the valuable building materials, and at the last but not least, to support the green building certification and sustainable development goals (SDGs). To produce the rubberized mortar, as you can see in figure 1, this is all the material required. The first is cement, and then silica fume, natural sand, rubber, and then graphene plate, and super plasticizer, Rodafak RM, which is this one is the Arabic gum, and then H is the mixing water. Figure 2 showing the preparation of the mortar sample for thermal conductivity test. First, we need to cut the cylinder, this sample cylinder, with a diameter of 50 mm, with a thickness of 1 cm or 10 mm, and then we cut by using this cutter, and then oven to make sure the no water inside this sample, and then after that to do the thermal conductivity test by using the Fox 50, as you can see in this figure 2.
Our objective is to develop high efficiency material with low thermal conductivity and at the same time with sufficient compressive strength for practical application. That's why we added two materials, rubber and graphene. Rubber was added to reduce the thermal conductivity, which is essential for energy saving, while graphene was added to substitute the compressive strength due to the addition of rubber. You can see compressive strength without rubber, without graphene, is 38 with only low content of rubber, 4%. With the increase of rubber to 18%, the strength reduced to 25 megapascal. But with the addition of 0.4% graphene, we can get compressive strength of 36 megapascal, which is higher than the design strength of which is 35 megapascal. It means with the combination of 18% rubber and 0.5% graphene, we can get 36 megapascal compressive strength, which is almost higher than the design strength of 35 megapascal. On the other hand, in terms of thermal conductivity, with the same combination, 18% of rubber and 0.0% of graphene, we can get acceptable thermal conductivity, which is 1.5, which is almost similar or smaller than the control. It means with the combination of rubber and graphene, we can get two benefits. We keep the compressive strength is higher than the design strength. At the same time, we get low thermal conductivity compared to 1.7.
For the application part, this mortar can be used as the wall insulation and slab insulation, panel insulation, and ceiling insulation, also for roof insulation. So as you can see in this figure, this is the wall panel, which is can be produced by using this material, yeah, the rubberized mortar, and then this mason block, and the floor screed and precast facade. The concept of insulation wall, as you can see here, the left side is the cool with the cool temperature, the right side is the warm temperature. So an insulation wall works by slowing down the transfer heat between the inside and outside of the building. It traps air, or in our case use a special material like rubberized mortar that can reduce the how much heat escape in winter or enters in summer. The expected impact of idea to sustainable development goals. By using this idea, we can support on SDG 3 on the good health and well-being. This one by providing the better indoor thermal regulation that can reduce the heat or cool related health risks and improve occupant comfort and productivity. And also, this idea will support SDG number 7 in terms of the affordable and clean energy. So, by using this rubberized mortar, so this will reduce the building heating or cooling demand. So this will reduce the required energy or electricity. Yeah. So the as expected outcome, this will lower the energy bills and reduce the peak electricity load in buildings. And also, this will support SDG number 8 on the decent work and economic growth, create a new value chain, for example, the waste collection, because this rubberized is produced from the waste, from the used tire, and also this will support the processing and composite production, and also this will support the local jobs and SMEs. Okay, for the impact on the environment, actually, because we are using the like the rubber crumb, yeah, so this considered the waste material, and will reduce will reduce the impact to the environment. And also because we are using this product for the building, that can reduce the uses of the electricity, yeah, so means we can save the environment as well, because most of the electricity is produced from the coal generation, the coal generator. They are using the coal or diesel. Yeah. So by reducing the depending on the electric, we can save the environment. Yeah. And then also this can be reduce the waste in the landfill, such as for the most of the rubber is produced from the tire, the old tire. And then for the rubberized component may come from the recycled material, so we can reduce the use of the natural resources or virgin resources. Okay. And then if we are using this for the building, we can produce the energy efficient building, yeah, by using this insulation insulator materials. To protect for this idea, and intellectual property in terms of utility innovation has been registered through Unit 10 R&D to be processed to the next step. Thank you.